Okay, this video is to help you with drawing 21A023 in your workbook. This is exercise is pretty similar to the one that you did previous to it. I just want to point out a couple of things that might help you along. Number one, you can figure that out on your own. Just flip back a couple of pages in your book and your workbook, and you should see the answer you need. Number two, you should already be aware of this, but if you're not, a fillet and a round are very similar. They're where you curve a surface, okay, curve an edge of a surface. The difference between the two, though, is a fillet is an inside curve, is concave, okay, whereas a round is on the outside, okay. And I believe they might actually have, and let me check that real quick. They might have that terminology in your workbook. Yeah, a fillet is a concave surface or an interior radius, whereas a round is a convex surface and it's an exterior radius. Okay, so when it's asking the question what size fillet radius is specified, make sure that when you look at the local notes given in drawing 218023 that you choose the right radius, okay, because one of the given radii is for a round, the other is for a fillet, okay. Actually, that's for number 3 too. So you'll have to decide which one's a fillet and which one's a round by looking at the workbook. Number 4, how many clearance holes are in the bottom flange? There are actually 2 flanges on this video. There's not video, sorry. In this drawing, here's the top flange, the smaller diameter, and the lower flange is the larger diameter. So all 6 of those holes in the lower flange are clearance holes, okay, and those are drilled, okay. That's by the way, this is number 5 that I'm talking about now. Those are drilled holes, and if you want to find the tolerance of a drilled hole, I think you're going to have to go to the unspecified tolerances section of your title block for this drawing, okay. Number 6, what is the tolerance on the bored hole? Okay, well the bored hole, if you notice at the top of the top view of the object, that's your bored hole. Okay, that's the most inside circle on the drawing. Okay, and it's wanting you to determine the tolerance there. And if the tolerance is given in the local note, then you can use that. If not, you'll have to go to the unspecified tolerances section of the title block to get your answer. Okay. Number 8, what size fasteners are intended for the holes in the top flange? Again, this is the top flange here. Okay, this is the smaller diameter flange, and you'll have to use the clearance calculations that we did in the previous video. And also, if you'd rather do the reading rather than watch the video, clearance holes are discussed about 2 pages back in your workbook. And number 9, how many surfaces are to be machined flat? All you have to do is to look for that machining symbol, and if you don't remember what that looks like, let me add one here. Okay, so that's what the machining symbol looks like right there, and you'll just have to count the number of machining symbols that you see, and that's how many surfaces are to be machined flat. Number 10, what would the overall height dimension be before machining? Consider finish allowance. Again, we did this in the previous exercise, and if you'd rather do the reading rather than going back and watching the video for the previous exercise, you can find that on 2 or 3 pages back in your workbook as well. And again, I actually gave you 2 answer choices there. Remember that the 2 dimensions that you account for are either 0.125 or 0.12, depending on if you're 2 or 3 decimal places. So, so there are 2 answers that will work for number 10. The dimensions A through J, it might take you a little while to figure them out, but they're not all too tricky. I did want to let you know that dimensions A, F, and H will all be 4 decimal place answers, and E will be 3 decimal places, okay? So the rest of them will either be 2 or fewer decimal places. So I just wanted you to be aware of that, and I think that is all I need to tell you about this exercise, and that concludes this video.